In this video, we will be talking about monomials, exponent laws, rules, and adding and subtracting polynomials. So a monomial is a number, variable, or a product of numbers and variables. So some examples include 4, 7x, and 3x squared. There's a bunch more examples than that. That's just some basic examples. If you want to write some more down, feel free to. So we're going to talk about our exponent rules, or I'm sometimes call them exponent laws. It just depends on what I'm feeling. So our product rule is when the base is the same and the exponents are different and you're multiplying the two together. So that means you're going to add the exponents. So for example, if we have x squared times x to the 7th, you would add them together, so 2 plus 7 is 9. So I'd have x to the 9th. Power rule is when you have something raised to a power, and then you take that and raise it to another power. So when that happens, you're going to multiply the exponents. So if we have x squared, and then we raise it to the 7th power, 7 times 2 is 14. So you have x to the 14th power. The quotient rule is when you have something being divided, and then you will subtract the exponents, as long as they're the same base. If they have a different base, then you can't subtract them. So for example, if we have x to the 7th divided by x squared, 7 minus 2 gives me 5. So I have x to the 5th. The negative exponent rule, if I have a to some negative m power, that means I'm going to move it to the denominator, and so put it over 1. So for the example here, if I have x to the negative 2nd, I have 1 over x squared. And the zero exponent rule should be your favorite rule of all time, because anything raised to the 0 power gives you 1. However, if you're raising 0 to the 0 power, it is undefined and does not exist. So anything raised to the 0th power is 1. Let's make that one not look funky. Okay. So there are a lot of examples in these notes, but we're going to stick with the odd examples, just for sake of not making this video 3 hours long. So number 1, I have 5x squared, and I'm multiplying it by negative 7x to the 6th. So when you do that, you multiply 5 and 7, negative 7. So that gives me negative 35. And then I have x squared times x to the 6th. And since they're the same base, I'm going to add my exponents together. So 2 plus 6 gives me 8. Let's do the first one. Alright, 3. I have 54m to the 6th n to the 4th divided by 3m squared n minus 10 m to the 4th 3n cubed. So let's deal with this thing first. So 54 divided by 3 gives me 18. And since these m's are the same, I can subtract the exponents, and 6 minus 2 is 4. And then, once again, I can do the same thing here with the n's, since the bases are the same. And I'm left with 3 n's. Then I have minus 10 m to the 4th, n cubed. And since these things right here, these exponents with the m's and the n's are the same, I'm allowed to subtract 18 from 10 and get 8. That is my solution for that one. Alright, 5 here. So I'm going to take 2/3 and square it. So 2 squared gives me 4. 3 squared gives me 9. R squared squared gives me R to the 4th. And S to the 7th squared gives me S to the 14th. And then I'm multiplying times 1/6, R cubed times S. So 4/9 times 1/6 gives me 2/27. And then I have 4 R's and 3 R's, so that gives me 7 R's. And I have 14 S's and 1 S, because there's like an invisible little one there. So it gives me 15 S's. So that is my solution. So this one here, 15 and 24, 3 goes into both of them. 3 goes into 15 5 times, and 3 goes into 24 8 times. So I'm left with 5/8. And then I have x's here. I have the x's here. So I'm going to subtract them. I'm going to get 10 minus 12 gives me a -2. And then I can subtract the 4's as well. The y's, and gives me 1. So since this x right here is negative, this exponent on the x is negative, I have to move it to the bottom. So I have 5y on top and 8x squared on the bottom. Feel free to do the evens. I will post the answers to the evens later. Give an example of two monomials with a quotient of -3n squared over m. So with that, I'm going to give you the example, but there's multiple different types of examples you could come up with. You want something that simplifies to 3 over 1. So -36 over 12 simplifies to 3 over 1, -3 over 1. You want something with an m in the bottom, so that m's have to be bigger on the bottom than on the top. And then you want 2 n's on top. So, no, I said 2 and meant to write 5. So you want 2 on top. So that's what we'll deal with monomials. Alright, polynomials is a sum or difference of many different monomials. That's why we talked about monomials first. The highest exponent of a polynomial we call the degree. And standard form is always written, you always write it with the exponents in descending order, so decreasing order. Descending order, and I will highlight descending for us. Alright. So I'm only going to do one of these because they're pretty self-explanatory, and I'm going to do 11. So when you're writing them in standard form and there's two variables, you start with the highest one in the alphabet. So we have a and b here, so a comes first. So I would have 4a cubed because a cubed is the highest. So that one's gone. We're done with that one. Then I have a squared. So plus 18a squared b squared. The b's just come with it. No big deal. And then I have an a. Plus 7ab, and then I'm left with b squared, negative. So that's now written in standard form. Alright, so to classify these guys by degree, we're going to fill in these charts over here. So if there's no exponent, we call it a constant. If it has an exponent of 1, we call it linear. If it has an exponent of 2, we call it quadratic. Exponent of 3, we call it cubic. 4 is quartic, and 5 is quintic. I would commit these to memory if they're not already, and if I can spell, we'd be better off. Yeah. So, I would commit these to memory because you're not going to be able to look at them later, like on a quiz or a test. So, number of terms. If there's one term, it's a monomial, like we talked about. If it's 2 terms, you write a bicycle, so it's binomial. If there's 3 terms, you write a tricycle, or you did when you were a little kid. So it's called a trinomial. And then if there's 4 or more terms, we call it a polynomial. Alright, so we're classifying these by degree and number of terms. We're going to use these charts over here to help us that we just filled in. So we're going to do the odds. Once again, we're just going to stick with the odds today. So 13, it has a degree of 1, so it's linear, and it has 2 terms, so it's a linear binomial. 15 doesn't have any x's or any variables whatsoever, so it's a constant. And it only has 1 term, so it's a binomial. 17 has an x squared term, so that is a quadratic. And it has 3 terms, so it's a trinomial. Alright, 19. A little different than the other ones. Give an example of a cubic binomial. So we want something x cubed, and we want 2 terms. So let's do, I don't know, negative 3x cubed minus 6x. I don't know, I'll just pick something. Feel free to use whatever you would like for that, as long as it's a cubic binomial. Alright. Adding and subtracting polynomials. This is where we're going to combine all of our like terms, so let me get my different color highlighters. So, we have x squareds, we have x's, and we have constants. So all I did was highlight them differently just so we can know what to add together. So 3 plus 1 gives me 4x squared. 11 minus 5 gives me 6x. And 4 minus 13 gives me negative 9. So that's the answer to that one. Three. So this one's a little different because we are subtracting. So we have 5k cubed minus 2k squared plus 2k minus 2k squared plus 2k. Just kidding. I didn't even distribute correctly. So subtract 2k minus 17. So let's pull out our handy dandy highlighters. If you want, you don't have to. I will, just for sake of my sanity. So k cubed, I don't have any other k cubes, I just have 5k cubed. Also, if you don't have highlighters and you want to do it, you can underline them in different, like, put 1 line under the x squareds, 2 lines under the x's, and 3 lines under the constants if you want. So there's k squareds, and here's my k's, and then there is my constant. Alright, so I have 5k cubed, I have negative 2k squared, and negative 2k squared gives me negative 4k squared. My 2k's go away because I have a positive 1 and a negative 1, and I'm left with a negative 17. So that's how you do those. 5 is a little bit different because it's telling you to subtract this thing from this thing. So this thing's going to go first, and then you'll subtract it from that thing. So let's write it out. AB squared plus AB minus 2A squared. So that whole thing minus this whole lovely thing. AB plus 7A squared minus B squared. Alright, so that's how you do that. I want you to try this one on your own. So now that you've tried this on your own, you will B squared, AB, A squared. Ooh, that's big. A squared. When you combine them all together, you get negative 9A squared plus 11AB plus 9B squared. That's how you do that. Alright. Now we're going to multiply polynomials. So we're going to do some distributing and some foiling, and it'll be lots of fun. My version of fun, not yours. I know yours is different. So we're going to FOIL here. 2x times 4 gives me 8x. 2x times negative 9x gives me negative 18x squared. 4 times 1 gives me positive 4. 1 times negative 9 gives me negative 9x. So that's what you do when you FOIL. We'll combine all the terms in a minute. And then we're going to distribute the negative 2x to the negative 3x and get negative 6x squared. And then negative 2x to the positive 11 gives me negative 22x. So now this is where our fun stuff comes in. So I have 8x, 9x, negative 22x. And then I have negative 18x squared, negative 6x squared, and then I have this little 4. So when I combine my like terms in standard form, so I'm going to start with my x squared, so I get negative 24x squared minus 23x plus 4. Alright, that's number 7. Let's move to number 9. So, I know what you all want to do. You want to take the 2c and cube it. And you want to take the 5d and you want to cube it. I'm going to tell you right now, if you do that, you're going to get it wrong every single time. Like, not even a little bit, not even possible. Nope. I won't give you any partial credit, none of that. So, when you do this, you have to do it and write it 3 times. It's already written once for me, so I'm just going to write it twice. 2 more times. So what you're going to do is you're going to FOIL. Pick 2 of them to FOIL. They're all the same. It doesn't matter. I will FOIL the last 2 just because I want to. And then we'll distribute this one into these guys once we do that. So, FOIL 4c squared plus 20cd plus 25d squared. If you need to watch me how to FOIL that, look back up here, how to FOIL. At this point, I hope you can FOIL. If not, come talk to me. We'll talk, and I'll teach you. Cool. All right. Now we're going to take the 2c, and we're going to distribute to each of these things. So 2c times 4c squared gives me 8c cubed. And when I do this, I'll do all the 2c's first. So 2c times 20cd gives me 40c squared d. 2c times 25d squared gives me 50c d squared. So that's the first part. Now to do the 5d. And when I do this part here, I will take whatever I multiply and I'll line it up where it goes. So d times c squared, it'll end up right there. So 5d times 4c squared gives me 20c squared d. 5d times 20cd gives me 100 cd squared, and 5d times 25d gives me 125d cubed. So now I'm going to add all these lovely things together. I'm going to get 8c cubed plus 60c squared d plus 150 cd squared plus 125d cubed. So that's how you do that. So that's how you multiply polynomials. Moving right along. Also, you don't need to do 12. I don't remember if it's crossed out on your paper or not, but you don't need to do it. We are just going to do 11. And 10 is for you to do. So x squared times negative x squared give me negative x to the fourth. X squared times negative 9x gives me negative 9x cubed. X squared times negative 4 gives me negative 4x squared. So that's the first piece. And then I'm going to, like I did on the other one, I'm going to line it up just to make it a little bit easier. So 6x times negative x squared gives me negative 6x cubed. 6x times negative 9x gives me negative 54x squared. And 6x times negative 4 gives me negative 24x. Negative 7. So negative 7 times x squared gives me negative 7. Actually, it gives me positive 7x squared because of the negative and the negative. And this negative 7 times negative 9 gives me a positive 63x. And negative 7 times negative 4 gives me a positive 28. So when I add all these lovely things together, I get negative x to the fourth minus 15x cubed minus 51x squared plus 39x plus 28. Also, if you want to figure out 12, you're more than welcome to. I might put it on there as like an extra credit, but I don't expect you to know how to do it. Unless you just really want to figure it out. If you do want to figure it out and you want me to help you, if you want to learn how to do it, come talk to me and I'll help you. Alright. So, once again, we're sticking with the odds because why not? We're going to divide polynomials and then write them in standard form. So 13, I have 9m cubed minus 24m squared over 3m. So all you're going to do is divide component-wise. So 3 goes into 9 3 times, and you're going to subtract your exponent, so you're going to have m squared left on top. And then you're going to have 3 goes into 24 8 times, and you have 2 m's on top and 1 on the bottom, so you're going to be left with 1. We have this lovely thing multiplied by this thing to the negative 1 power. Well, we talked about the negative 1 power at the beginning of this video. So what you're going to do is you're going to change this to 1 over 2ab. So you're going to divide this whole thing by 2ab. That's all that means. So when you do that, 2 goes into 14 7 times. I have 3 a's left and 2 b's left. And then I have 2 goes into negative 20 10 times. I'll have 1a and 1b left. And then 2ab goes into 2ab exactly 1 time. So you have to write the 1 for it to work. If you multiplied it back out, it wouldn't show back up. So you have to make sure you multiply back out. 17. You're going to take and divide 3x squared into all of this thing up top. So 3 goes into 30 10 times. And then I have 1 x left over. 3 goes into negative 12 4 times. No x is left over. 3 goes into 9 3 times. And there's 1 x left on the bottom. So you can either write it that way, or you could write it and leave it as a negative exponent. I don't care for this one. I would prefer it the top way, however, I'll accept it the bottom way as well.